Today's class I am going to talk about how to represent the number in system Verilog. So here I make the table. So in this table we have different columns. That column mention number, bits, base, value and stored values. So before I explain the table, first I touch the basic things for representation of number systems. So first I write the syntax. N tick B value. So this n represent number of bit. So n represent number of bit. B represent base value. So this value is the data. So example 3 tick B 101. So this syntax is I rewrite like this. So 3 tick B 101. This 3 represent number of bits. So number of bit present in the instruction. So this 3 represent number of bit and B. So B represent base value. So here this base value is binary. So base value like binary. So B represent binary. O represent octal. D represent decimal, H represent hexadecimal. Then this value is the bit. So stored values. So it's an example of this number system representation. So let me consider one example, another example. So W value equal to 6 bit. So W value equal to 6 bit. Assign W equal to tick B 11. So you just compare these two examples. So here 3 tick B 101, but here W equal to tick B 11. So one term is missing. So that term is number of bit. So here mention 3. So this value is compulsory 3 bit value. But here that number of bit is not mentioned. Before that I declare W value is a 6 bit wide. So in this instruction W value is a 6 bit wide. It's defaultly understand. So after execution of this instruction W value is 000011. So it's a 6 bit value representation. So now I am going to explain the table. So first one 3 tick B 101. So this 3 represent number of bits. So number of bit is 3. Base value. So base is binary. So binary in the sense base value is 2. Then next one value. So value is 101. So 101 is the value. Then stored bit. So stored bit also 101. 3 bit value. Then come to second one. So here the number of bit is not mentioned. So n is not mentioned. So just mention tick B 11. So tick B 11 in the sense the bit value is, we don't know the bit value. Then come to base. So base value is 2. So 2 is the base value. Then value is 11. So 11 is the value. So how to store this bit value? So it's stored like this. Because we don't know the number of bit. So it defaultly take this like this. Defaultly take like this. Then come to next one 8 tick B 11. So 8 is the bit representation. So number of bit is 8. Then base value is 2. Then value is 11. Then the stored bit is 8 bit value. So 00000011. So it's a 8 bit value. Then come to next one 8 tick B 1010 underscore 1011. So this underscore is represent the better readability. So 8 is a bit. Then B represent base value 2. Then the value is 171. So how to find this value? Using 8421 code. So 1248 1632 64 128. So just add this value 128 plus 32, 130, 160, 168, 170, 171. So value is 171. The equivalent stored value 10101011. So it's a equivalent stored value. The next one is 3 tick D6. So these 3 represent bit, number of bit is 3. D represent decimal value. So decimal equivalent base value is 10. Then 6 is the value. So 6. 110. So it's a output stored value. Then 6 tick O42. So 6 is the number of bit. This O represent octal. So it's a octal number system. So octal equivalent base value is 8. Then 42. So 42 equivalent decimal value is 34. So 32 equivalent stored value we will find here. So 1, 2, 4, 8, 16, 30. So 32, 1, then 2. Remaining all the places put it 0. So it's a 34 equivalent binary number. The next one, 8 tick HAB. So 8 is the number of bit. H represent hexadecimal value, that equivalent hexadecimal base is 16. Then AB. So AB equivalent decimal number is 171. So 171 equivalent binary number 10101011. So it's the equivalent binary number for 171. The next one, 42. So this instruction they won't mention the number of bit and base values. So here bit is don't know, then base value also. Base value is defaultly take decimal, so decimal in the sense that's a 10. Then 42. So 42 is the decimal number, that equivalent value, binary value. So 1, 2, 4, 8, 16, 32. So 32 place put it 1 and 8, 2. So 32 plus 8, 40, 42. So remaining bits put it as 0. So it's a equivalent value. Then come to next one, tick 1. So in this instruction also they don't mention number of bit and base values. So here number of bit don't know, base value not applicable. Then so this value is nil. Then the stored value 1 1 up to 1 1. So in this case all the bits set to be 1. So like this we represent the numbers in system Verilog. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make a lot of videos. Thanks for watching my channel. Thank you.